Welcome to bsk8s, a video series that explains Kubernetes topics in bite-sized chunks. So in 10 minutes or less, we will cover a specific Kubernetes topic, and today we're talking about containers. In a nutshell, containers work like this. On your local machine, you write some code, and then you write a Docker file. And that Docker file contains something called a base image. And on top of that base image, you add your local file. And once you've done that, you run a simple build command. And when you run that command, you get something called an image. And that image is pushed to something called a registry, which is basically a fancy database that stores container images. Then, from any machine, whether it's yours or somewhere else, maybe running in the cloud, you can pull that image and run that code with a single command. So far, we've been using the terms image and container, and it may seem almost like they're interchangeable, but they're actually two different things. So when you start with a Docker file, you build that Docker file into an image. And that's roughly the equivalent of explaining to an architect what you would like a building to look like. And then that architect will sit down and draw out a blueprint. And so the image is roughly the equivalent of a blueprint. And then when you run that image, you get a container. And that is the equivalent of converting a blueprint into a finished building. So an image is to a blueprint as a container is to a building. You may have heard containers being described as lightweight. And the reason for that is that they represent only the topmost layer of a Linux operating system. So while there are multiple layers, the Docker file itself only contains information related to the application layer. And so actually, when you run a container on a Linux machine, you're using the underlying machine itself for the bulk of the operating system, and you're only having to push and pull from machine to machine that very topmost layer of the operating system, the application layer. Next, let's talk about what's in a Docker file. Remember that we said the Docker file represents only the topmost layer, the application layer of a Linux operating system? Well, we get the bulk of that information in the very first line of our Docker file, which is the from command. And this is where you define the base image upon which you're going to build. So in this example, the command is from Ubuntu latest. And so what we're starting with, before we add any additional code or install any additional dependencies into this image, we get a full Ubuntu operating system. And the latest part of that command is called a tag. And for images, tags are simply an easy and convenient way to differentiate between versions of a given image. So, the latest version is the version that was most recently released. But if you wanted to specify a specific Ubuntu version, you could pass that as a tag. Next, let's look at some additional commands that you're going to find in a Docker file. There are actually a variety of commands that you can include, and for a full list of those, you should check out the Docker documentation. But for our purposes, we're going to include the commands from that we just talked about, copy, run, and the command. And for each command that's included in the Docker file itself, an intermediate image is built and cached on your local machine. So we start with the from Ubuntu command, and notice on the right we have a stock Ubuntu operating system. Then we have a copy command where we copy a local file into that new operating system. And when we do that, we get the Ubuntu operating system plus that new file that we've just copied as a distinct intermediate image that is also cached on our machine. Then we run a command inside of that Ubuntu operating system that includes that new file, and we build a new image, and that image contains the packages that were defined in the requirements.txt file that we just ran pip install against. If you're not familiar with Python, this is just the standard way to manage your dependencies in Python. It works the same way for all languages, more or less. And then we run an additional copy command where we copy our code.py file into that new image, which again creates a new intermediate image. And finally, the Docker file includes a command, which is the command that will be run when we start this Docker container. And so we basically, in this case, are just going to run that Python file when we start the container. So to summarize, a Docker file contains a series of commands that run in order, so from the top to the bottom. And for each command that is included, a new intermediate image is built and cached on your local machine, and then finally you get the final image that is ready for you to run. You might have noticed that in some of the commands that were included in our example Docker file, there's a dot or a period at the end of the command. And this might be a little bit confusing if you're not familiar with it. But the reason that that's included is because we need to tell Docker where we want this file to be copied to and where we want it to exist when we start that Docker container. So remember that we started with a base Ubuntu image? Well, in an Ubuntu operating system, there's a file system. And there's a root directory, and then there's a bin directory, and a temp directory, etc., etc. And we need to tell Docker exactly where in that file system we want this file to be so that we can run it as we would expect. And in this case, we're just adding it to the root directory of the file system. So although we could specify a specific path at which we want this to be copied, we're just going to stick it in the root directory of that file system. And that's what the dot's about. And next we'll look at the terminal commands that will make all of this work. But to do that, we're going to have a simple example file here. And basically what we've got is a very simple Python program that will print the container is running over and over again in a loop. And just like in our example Docker file we looked at earlier, we're going to start with a from command, which is going to be a Python 3.10 image. Then we're going to copy our new Python application, which is defined in main.py. And then finally, we're going to include the command that we want to run when we start this container, which is just, again, the command that is going to run that application. So in this case, it's Python main.py. And now that we have our Docker file and our main.py file defined, let's go ahead and build that with this docker build command. So notice that we have the docker command with the build subcommand, and then we give our image a name. And in this case, I've started it with JD Vincent because that's my Docker Hub username, and that's going to make it simple to push to Docker Hub later. Then we called it example with the tag of latest, and we gave it that dot to tell it that the Docker file is actually in the same directory that we're working in. And next, let's run that image as a container on our local machine with a docker run command. And just like we expected, we see the output printed to the terminal. The container is running over and over again in a loop. And with that, let's go ahead and finally push this new image to Docker Hub. We're going to start by logging into Docker Hub, which is a free registry. If you remember earlier in the video, a registry is just a fancy database for storing images. And then we go ahead and run our docker push command with our same image name. And now that image is stored in the cloud and can be pulled from any machine. I hope you enjoyed this video. Please check out the others in the bsk8s series, and happy developing.